So in 3.3, we're finding out that there are some triangles where you cannot use the sine law. And that, of course, happens when you do not have a side length and an opposite angle pair where you're given both of those. So in this case, this is one of the cases. So how do you know that? If you see a triangle situation where you are given a side and an angle and a side that are all in a row, like this, side, angle, side, triangle, that is a situation where you cannot use the sine law. Okay, yes?
Seems like a situation where you can use the sine law is where for a side or an angle, like at least four of those would be able to be known.
Okay, well, let's take a look at the second one. Okay, so is four the right number? Well, maybe. What about this second situation? This one is different. This is a triangle situation where we aren't given an angle at all. Okay? And so we have side, side, side. So when we're given a side, side, side situation where all three sides are known but no angles, that's another situation. So back to your point, where you need at least four. Well, let's see. If we had four things, three angles and one side, that would work. If we had three sides and one angle, that would work. If we had two sides and two angles, would that work? Two sides and two angles. Yeah, it would actually, because let's say we'd have one of these, right? We'd have S, we'd be given that, so we'd have a pair. Or we'd be given this one, and we'd have a pair. So if you have four pieces of information, then you're good to go. But if you only have three, sometimes you can't use the sine law. Okay, so side, angle, side, and side, side, side. Those are the situations where we can't use the sine law. Now, in another video, I go through the proof, okay, and this is what it looks like. I go through the proof of the cosine law. I'm not going to do that today for sake of time, but we can dissect a triangle, and we can use sort of the similar reasoning that we used to prove the sine law. We can use that to prove the cosine law. So I'm not going to do this today, but this is the cosine law here, and I'm just going to talk to you about it this way, okay? So as we move back over here, all right, we know that we can use SOHCAHTOA for what kind of triangles? What kind of triangles does this apply to, SOHCAHTOA? Right triangles. Very good. Right triangles. All right. So what happens if we have a triangle that is almost a right triangle? Let's say that this is not 90 degrees, but it's 89 degrees. 89. Okay? Do you think that a squared plus b squared, actually I'll just write that as just a, that a squared plus b squared would be pretty close to c squared? Like approximately c squared if this was just 89? Or what about if it was 89.9? Would we be pretty close, do you think? Well, what happens if this was 88? Would it be close? Probably still be close, but it wouldn't be exact. Now, if we started to get away from this, if we started to get further and further away from 90, you can understand that we're going to be further and further away from this situation being true. So the quick version tells us that, hey, going from a right triangle where we know this to be true for a right triangle, if we move away from a right triangle, there are some aspects of the Pythagorean theorem that are true. We just have to have a little adjustment factor. And the cosine law is basically the Pythagorean theorem with a little bit of an adjustment factor. So once again, I'm not going to go through this proof over here. I have the proof over here. And if you want to watch that video, you certainly can, where I go through step by step. But look over here. This is the adjustment factor right here. It's a little complicated, but it's called the cosine law because the adjustment factor includes a cosine. All right? So this is it right here. And I may as well just kind of clip and copy this. Let's bring it over. So again, without showing you the proof, I'm going to give you the law here. And this a little adjustment factor is this right here. Okay? So we have the Pythagorean theorem plus an adjustment factor because, look at, this is angle C right here. See that? So we have to acknowledge and account for the fact that C is not a right angle. Consequently, what is, now this is, I think you'll find this to be cool. I don't know, maybe it's teacher cool and not kid cool. However, I think this is helpful. If C was 90, what is, the cosine of 90? Go ahead on your calculators right now, check out what is the cosine of 90. I'm going to do it as well. Cos of 90 degrees. And you get a big fat 0. You get 0. So look at this. If we are talking about a right triangle, because cos of C, because this is 0, guess what? This whole thing, because they're all multiplied together, is 0. And if C is 90, what do we have? We have the beloved Pythagorean theorem. But if cosine is not 90, if it's close, let's just see, what about cos of 89.9? Do you think that's going to be what? Any guesses? Close to 0, close to something else? Let's see. Oh my goodness, look at that. It's very close to 0. So if we are off by just a little bit, here's this factor that we have to take into account. And guess what? This right here, the Pythagorean theorem, is only off by a little bit. And on our calculator, we see that cos of, let's say, 88.9 is actually just a little bit. Okay, so, so this is what I'm suggesting. The cosine law works in situations where the sine law doesn't. And how do we know that to be true? And I'll just finish this if your cos of 90 is 0. So here's the cosine law, and you'll see this in your textbook, all right? And how does the A and the B and the C, how does that work out? Well, this right here is what I just wrote on the board. But really, if there's no 90 degree, there is no side that has to be C, right? So if all the sides are different lengths and there's no 90 degree angle, really, we could talk about any side and we could interchange the letters. So let's see. Let's take a closer look at this and see what's important with the cosine law here. Okay? What's important is this, is that, let's take a look at this here. Now, if you have a squared, let's say, this side squared, it's by itself on one side of the equation. It's equal to the sum of the squares of the other two sides always. If this is A, then this is B squared plus C squared. It's always the other two sides. We notice that this is always minus. This right here is always 2 times this value and this value. Okay? And it's multiplied by cosine of the angle that is opposite the side that's on this right here. You see how those are related? So the pattern is always the same. Let's do that once more. The second version, B squared equals, well, the other two sides are A squared plus C squared, so A and C. We always do a minus. We always have a 2 here times whatever value A was and C was, so these two values right here. And then it's always times cos of the angle that's opposite of this side that we started with. So finally, C squared equals A squared plus B squared minus 2 AB cos C. All right. So I'm going to let's zoom back out here. All right. So on this question right here, and I'll encourage you please to write this one down. Write this example down. Just draw this little triangle right here, triangle ABC, with these side lengths and this angle. So just take a moment to do that. All right, so now that you've copied this triangle down, let's take a quick look here. So what situation do I have? Can I use the sine law? Well, I have side, angle, side. I do not have a pair of an angle and its opposite side that's known. I do not have that situation, so I can't use the sine law. I have to use something different. This is where we use the cosine law. So guess what? Here is A. It's opposite of big angle A. This is little b, side little b, and so on. All right? And this is side little c. So what I'm trying to find is the length of CB. That is A. That's little side A. So guess what? I am going to start with A squared. That's the side I'm trying to find. So I'm going to start with that on this side. Now you help me out. From what we know, what do I put over here? B squared plus C squared. Okay, stop right there. Good. It's the other two sides squared, right? Sum of the other two sides squared. Now is this a plus or minus? Minus what? 2. Which ones do I use? Ah, these two. B times C. And then this is the cosine law, so you got to put cos on there. And cos of what? Of big A, right? Awesome. Now, this is great because I have B, I have C, so I have them there and there as well, and I have angle A. So this is going to be great. I'm going to be able to use this law, I'm going to be able to find A. So remember this is A squared, so let's just write that down as A squared. So B is going to be, and I'm just going to show this step here, full out here. Okay, so this is what you do. Okay, so that's how you would fill this in. And then you could just get your calculator to give you some help here, of course, and I'll just maybe do that. All right, so I put that in my calculator and I got 1267. So remember, A squared equals 1267 and change there, 0.4066. And so what we want to do is we want to find A, not A squared. We're not interested in A squared. And so we do the square root and use your answer button to put that whole decimal in there, and you'll get something that's very, very accurate, 35.6. So A should be 35.6 once we take the square root of both sides. Okay, and what are the units there? Well, we were given meters, so our units for this answer are meters. All right, any questions about that? We okay? All right, so let's do one more example where we're trying to find an angle now, okay? So let me find an example. We'll just do one more where we're trying to find an angle. Oh, here we go. Here's example 2. We're trying to find an angle, and it is B. Now, I would suggest that you memorize the cosine law. Not going to be that hard. We're already halfway there from what we've done today. And I would suggest that you start off by writing down the cosine law the same way every time. Doesn't matter if you're looking for a side or an angle. So what I'm suggesting is this. Even though we're looking for B, don't put B on this left side because you're going to have to memorize what B equals. You have to memorize all that manipulation, the dividing, the cos to negative 1. All that. Yeah, just go ahead and write it the same way that we've been memorizing. So I'm going to use, I need B, so I'm going to start with B over here on this side. So I'm going to do B squared equals. Now, I'm going to write out the whole formula just so we can get some more practice at it. Okay. And I'm going to fill in my numbers. So this is going to be 20 squared equals 19.5 squared plus 10 squared, and so on. And then I'm going to leave B on its own because that's what I don't know and that's what I want to find. So there's a couple extra steps you're going to need to do here to solve for B, okay? And you need to be patient with this, all right? Because a lot of kids over the years I know have messed this up royally. So don't try to do too much at once. Notice that these two terms here are separate and they are added together. This is one big fat term here. So these are going to be subtracted off. This part has to be divided off. Please don't mess that up. And actually, I should have even included that negative sign in what has to be divided off. So I would suggest do this. If you want to evaluate 20 squared right now, you totally can. I'm just going to do this so you can see the same stuff. 19.5 squared minus 10 squared. Okay, so you see I've brought these over to the other side. See that? Yeah, as minuses. So I'm going to subtract them. Now, if you wanted to, you could see that I have negative 2 times 19.5 times 10 times cos B. And I want to get rid of this. So now because it's on its own there, I can divide this off because they're all being multiplied by cos B. So guess what? You can do this. Divide by negative 2 times 0.5 times 10. Okay, and that will leave you with cos of b. So just be careful that you subtract the right things and you divide the right things, all right? And make sure you don't forget this negative sign here too. That's going to be super important. Your calculator will reject you if you miss a negative sign like that. It will. So let's just see if I've done that correctly. Okay, so 20 squared, okay, minus 19.5 squared minus 10 squared. Okay, that's what's going to be in my numerator here, negative 80. I'm going to divide that by the product of these. So negative 2. Right? I should probably add another bracket. Negative 2 times 19.5. Wow. Once I get started with the brackets here, I have a tough time knowing when to end. Okay. Times 10. Okay. Now I've got everything in the denominator there, right? So you got to make sure you divide by all of that. And again, I'm showing every little piece of the work here. So let's see. 1, 2, 3, 4 left brackets, and 1, 2, 3, 4 right brackets. Okay, I should be good. Ah! I just hit clear. Okay, what a dope. All right, so we got 0.2057. Switch those around. 20576923, and equals cos of b. Okay, so notice that this has to be less than 1. Okay, to find a b angle, this number has to be less than 1. And if it's positive, negative, it's going to turn out to be positive. So how do you find b? Well, you should know how to do that. Second function cos, right? So cos of the negative 1, and you can just use your answer there. So 78.125. Did anybody else get that? 78.125 or 78.1 degrees. Okay, so a couple extra steps there to solve for the angle, but totally can be done. No problem. Questions?